Our mathematics topic, differentiation, and this is the second example of how to sketch curves using differentiation to find stationary points. So example 2 is f of x equals 2x squared minus x to the power 4. So we go through the 4 steps again. We're going to find the y-intercept. We set x equal to 0. We do that, we find that f of 0 is just 0. So 0, 0 is our our y-axis intercept. Of course, that will also be an intercept of the x-axis because it's the origin. So we now find the x-intercepts, we set y equal to 0 and we solve. This is a bit more difficult because it's 2x squared minus x to the power 4 equals 0, but we can factorise that. We can take out x squared as a common factor, leaving x squared giving x equals 0 or x squared equals 2. So x equals plus or minus the root of 2. So these are slightly strange, but we have 3 intercepts, 0, 0, minus root 2, 0, and root 2, 0. And again, I'm going to box those points so that I know where they are when I come to draw the sketch. So I've got 3 roots. Next, the most important part, to find the stationary points. Now we need to find the solutions to f dash x equals 0. So this is relatively easy to differentiate. We have 4x minus 4x cubed. We make that equal to 0. We factorise, and we get 3 answers again here. X equals 0, there's a stationary point, and x equals plus or minus 1. All 3 of these need y-coordinates, although we happen to know already the y-coordinate for x equals 0, but we need to work out for x equals minus 1 what f of minus 1 will be. That's 1. And at x equals 1, we have f of 1 is also 1. So there are 3 stationary points at minus 1, 1, 0, 0, and 1, 1. Remember, you can pause this video and study the solution carefully. Make sure you understand all the steps and ask questions if you do not. We now need to finish by looking at large and small values of x. Oh no, sorry, we have to find the nature of these stationary points first of all. So here are my nature tables. We're looking at x equals minus 1, x equals 0, and x equals 1. So all the things that we normally do, we have the factorised version of f dashed x here, or we can put it along the top. And we need to be careful choosing the value after minus 1. We can't use 0 because it's a stationary value, so we use minus a half. So I'm going through all those steps that I normally do to find the sign of f dashed x at these values. Here it's positive, here it was negative, just by putting it into this factorised version. So we find a maximum, a minimum, and another maximum. We're then able to sketch this function, although we normally do look at very large and very small values of x as well, which I've neglected to do here. In any case, we have our intercept at minus root 2, 0, 0, 0, and root 2, 0, 2 turning points here at minus 1, 1, 1, 1, and a turning point at the origin. And we can sketch that curve as follows.